Are you able to see my screen?
Yes,
Sorry, are you able to see my screen?
yes, sir. Yes, sir. Yes, sir.
Yes, sir.
Okay, fine. So, if you see, we are discussing about appurtenances. Fine. So, what is appurtenances and what are the different appurtenances which we need to look? We have discussed in the previous class, and then we started with manholes. We discussed about different types of manholes, and then few were left in the last class, which we will be discussing in today's class. Now, the side entrance manholes, I guess this was the last appurtenances which I discussed. So now going forward, the next important one is drop manhole. Now, what is drop manhole? You know that the main significance drop manhole lies, when a branch where enters a manhole by more than zero point 0.5 to 0.6 meter above the main sware, the sware is generally not allowed to fall directly into the manhole. So the main idea is to accommodate the difference in the elevation by the help of appurtenances or manhole. So such type of manhole is called as drop manhole. Now from the name itself, you should be able to know that it facilitates dropping in the elevation. So we don't provide direct dropping from some height. So that is why there are some appurtenances, and drop manholes is that kind of appurtenances which facilitate the dropping of swage from one elevation point to another one. Right. So, uh, so any difference in the level between inverted level of branch wear and water line in the main sware at maximum discharge is greater than zero point 0.6 meter, a manhole may be built. So that is the criteria for the drop manholes to be constructed. Fine. So if that elevation difference is more than zero point 0.6 meter, a manhole may be built either with a vertical or nearly vertical drop pipe from higher sware to lower one. So that can be seen in the figure here. So we have that sectional elevation from both the direction, and you can see in the right hand side what we are doing is we are actually the same thing which we are talking about. So the branch where is coming to the main square, and then there is a difference in the elevation, and that has been accommodated by the help of drop manholes. So the drop manhole is also required in the same sware line in sloping ground when there is a drop more than zero point 0.6 meter. It is required to control the gradient and to satisfy the maximum velocity, which is non-scouring velocity. So not only in the case where where you have a junction of the branch sware and the main sware and the elevation difference is more than zero point 0.6 meter. Apart from that situation, where you have sloping ground and you need to restrict the maximum velocity within the limit of non-scouring velocity, you can use drop manhole as an option to reduce down the excess velocity because of the gradient. So these are the different situations for which drop manholes are used. Fine. So the construction of drop manhole, in place of ordinary manhole, in case of high level branch where enters a low level mains where, and there are several you know ways you can construct the drop manholes, but the schematic diagram is a common representation or usual representation, and the construction is more or less similar to the manhole which we discussed before. So what is done is, in this case, a plug is provided at the point where branch were, if taken straight, intersects the wall of the manhole. The length of the branch where between the vertical pipe and the plug is known as inspection arm. Fine. And that can be used for inspecting and cleaning the branch were after opening the plug. So these are the process by which basically the cleaning of branch wear is done within the drop manhole. Now with this we'll move to the next appurtenances. So that is a scraper. So what is scraper? So all sewers above 450 mm in diameter should have one manhole at an interval of 110 to 120 meter of scraper type. Now, these manholes will have clear opening of 1.2 to 0.9, 1.2 by zero point 0.9 meter at the top to facilitate lowering of the buckets. Now, these spheres are basically service. The scrapper manholes are basically service manholes, so it should be provided even if you don't have any problem in the line. You need to provide it with an interval of 110 to 120 meter for the purpose of service, and that is what is known as scrapper type manhole. So next is the flushing manholes. So what are the purpose of putting flushing manholes? So in flat ground for branch wears when it is not possible to obtain the self-cleansing velocity. So from the name itself, you should be able to understand the flushing manholes. Now the flushing manholes does exactly the different thing or the opposite purpose of what we have in case of drop manholes. So in this case, when it is not possible to obtain the self-cleansing velocity at all flows due to very little flow, it is necessary to incorporate flushing device. And this is achieved by making grooves at intervals of 45 to 50 meter in the main drains, in which wooden planks are inserted and water is allowed to head up. Because of this additional head, that would actually enhance the velocity and would help to maintain the self cleansing velocity in at least once in a day. Or when the planks are removed, the water will rush with high velocity, facilitating cleaning of the sewers. Now, alternatively, flushing can be carried out by using water from the overhead water tank through pipes and flushing hydrants, or through fire hydrants or tankers, or by the use of hose. So these are the process by which you can maintain the self cleansing velocity, and that is very much required to be maintained. Fine. So scrappers are, though it seems that it is another one type of manholes, but this has significant, sorry, flushing manholes has a significant, impact in smooth running of the sewer lines, because you help in maintaining self-cleansing velocity by the help of constructing flushing manholes. So remember the difference between the you know working principle of flushing manholes and drop manholes. Now with this we'll move to the next important uh, appurtenance. So what is inverted siphons? Many of you have heard this term inverted siphon. So an inverted siphon or a depressed sewer is a sewer line that runs full under gravity flow at a pressure above atmosphere in the sewer. So in this, it is always, it has to run in full, because this is under pressure. Not only it is actually run more than atmospheric pressure with a which is more than atmospheric pressure. So when you have more than atmospheric pressure, that means we can consider this that this would run full. Fine. So inverted siphons are used to pass under obstacle such as buried pipes, subways, etc. So when you have such kind of formations, what you want to do is you want to just basically lower down your sewer lines, and that can only be achieved with the help of inverted siphons. So wherever you need to depress the sewer lines, you can think of constructing inverted siphons. So as the inverted siphon requires considerable attention for maintenance, it should be used only where other means of passing an obstacle in line of the sewer are impracticable. So The maintenance of inverted siphon is very sophisticated, and if you don't maintain it properly, it will end up clogging or choking, and that will be a catastrophic problem once it is connected to the menswear line. That is why if you have even one options to avoid constructing inverted siphon, it is usually practiced that that particular option will be taken over the construction of inverted siphon. So that is why even if you have this option of constructing inverted siphon, its maintenance is quite difficult because it is always running in full, and that is why we should be always careful while dealing with inverted siphon. Next is lamp hole. So lamp hole is a very interesting appurtenance. So this is nothing but an opening or hole constructed in a sphere for purpose of lowering a lamp inside it. Now it consists of a stoneware or concrete pipe which is connected to the sphere line through a T-junction, which can be seen in the right hand side bottom figure. So at the top we have a chamber like manhole cover, and then there is a particle pipe which is directly connected to the sphere lines, and the lining is either made up of stoneware or made up of concrete, and the pipe is covered with concrete, like what we have seen in case of manhole cover. Now manhole cover of sufficient strength is provided at ground level to take the load of the traffic, same in case of lamp hole. If the sewer length is unobstructed, the light of the lamp will be seen, and it is constructed when the construction of manhole is difficult. Now in presence practice, as far as possible, the use of lamp hole is avoided because the lamp hole can also be used for flushing the sewers. This is very important. When you are unable to, construct flushing manholes, what you can do is you can use this lamp hole to use them as a flushing manholes, and you can take out water from the other storage device or maybe fire hydrant, and you can just use them to achieve the self-cleansing velocity. So remember, we have to achieve non-scoring velocity. We have to uh, be within the limit of non-scoring velocity, but we have to be more than the uh, self-cleansing velocity, so that we can ensure that everything, all the solid part is going smoothly through the swear lines. Otherwise it will end up choking the swear lines or swearing systems. Now, so this is what is all about lamp hole. Now we will move to the next one. So that is the clean outs. So the purpose of clean out is just to clean. So it is a pipe which is connected to the underground sphere, and the other end of the clean out pipe is brought up to the ground level, and cover is placed at the ground level, as shown in this particular figure. Now a clean out is generally provided at the upper end of the lateral sphere in place of manholes, because in all the points constructing manhole is very very cost consuming, I would say. So that is why in few places where the construction of manhole is not required, the cleanouts can be provided. During blockage of pipe, the cover is taken out and water is forced through the cleanout pipe to lateral swers to remove obstacle in the sewer lines. Now for large obstacle, flexible rod may be inserted through the cleanout pipe and moved forward backward to remove such obstacles. Now if you create such cleanouts after a certain distance, with a constant interval, as wherever it is required, and then if there is a chance of blockage of pipe or clogging of pipe, that can be easily taken care of by the help of cleanouts. Either you can put water jet just to clean up, remove the clog, or you can use some flexible rod which would not cause any harm to the menswear line. However, that would help to get rid of from the blockage. So this is the main purpose of putting the cleanouts. Now the next appurtenances which we are going to discuss is inlets. Fine. So what is inlets? Inlets are basically, stormwater inlets are provided. Inlets or stormwater inlets, they are provided to admit the surface runoff to the sewers. Now, right, basically when you have huge amount of storm water coming on the surface, so that water also has to be, dispersed somewhere, to avoid water clogging in the locality or in the, traffic way, or in the railway track. So that is why, proper inlets are provided, and these inlet would facilitate, taking that extra runoff to the sewers, and they are classified in three major groups, such as carb inlet, gutter inlets, and combined inlets. So we'll be discussing subsequently these three type of inlets. Now they are provided either, depressed or flush with respect to the elevation of the pavement surface. If you go through any, chalk, or what we say, any intersection, or um, any junction point, in the traffic system, so you will see so many different inlets, and those inlets we will be discussing. And once I discuss, many of you will be able to understand what you might have seen before. Now you will be able to relate them. Now what is done is, the structure of the inlet is constructed with the brickwork with cast iron grating at the opening, conforming to Indian Standard 5961. So where the traffic load is not expected, fabricated steel grating can be used, whereas the clear opening shall not be more than 25 mm. The connecting pipe from the street inlet to the spheres should be minimum of 200 mm diameter and laid with sufficient slope, so that, there no water choking or clogging in between. Now a maximum spacing of 30 meter is recommended between the inlets, and which depends upon the road surface size and type of the inlet, and as well as rainfall. Now, this is not a sacrosanct rule that you need to put a spacing of 30 meter. It can be maximum 30 meter, and it can be minimum, depending upon what type of road it is, how much is the total surface area, how much is the, what type of inlet you are going to use, and what is the average rainfall of that area. So, depending upon that, we can basically decide which type of, you know how much should be the spacing and which type of inlet should be used. Now the first one is carb inlet. Now these are the verticals opening which have been shown in the left hand side photo. You can see that these are the vertical opening in the road curbs through which stormwater flow enters the stormwater drains. Now these are preferred where heavy traffic is anticipated. So that means, you will not, the traffic load will not come at the top of the slit or the cover. So that is why you can avoid breaking those covers, frequently. And when you have high traffic load is anticipated, we prefer to construct carb inlet, because in this case carb opening is vertical. So from the section you can see the level of footpath, the concrete box which facilitate the accumulation of the storm water, and then finally that will be conveyed to the stormwater drain. Now the second one is the gutter inlet. So these are the horizontal openings in the gutter which is offered by one or more, grating through which stormwater is admitted. Now in this case, gutter inlet, we have horizontal, opening covered with grating, you can see, and you have road. So from the road, by the help of natural slope, as precipitous, the runoff will come, and then directly it will go to the concrete box beneath the cover with grating and within the gutter inlet, and then finally that water will be sent to the stormwater drain by the help of gutter inlet. Now we have combined inlets. In this case, what happens is we have the carb and gutter inlet both, and they are provided and they act as a single unit. Like, some amount of water moves through the carb inlet, and some amount moves through the gutter inlet simultaneously. Fine. So hope you have understood now. Whenever you have 4 point junction in the road, you can go and you can observe, and you will be able to see these two type of curve inlet and gutter inlet. And in these days, you will be able to see combined inlets as well. Now, combined inlet consists of curve and gutter inlet. So even if you see combined inlet, you can recognize which one is curve inlet and which one is gutter inlet. So this exercise would help you to understand better, because we are unable to show it during this theory class. Next is very important one, so that is the catch basins. Now I forgot to mention one thing, that street inlets are also called as gullies, right? Street inlets are also called as gullies. So next is catch basins or catch pits, fine. So catch basins are nothing but the street inlets provided with additional small settling basins, which can be seen here. So how you are creating? You are creating these by creating a special type of outlet from the catch basins or catch pits. Now, what is the main purpose of putting this catch basin or catch pits? What happens is when the storm water mm, comes and gets accumulated within such chamber, so the grit and sand and debris, etc., do settle in these basins, and then their entry into the sewer is thus prevented or reduced as far as possible. In addition to this, a hood is provided. You can see from the figure, and through that the foul gas would escape. So that is another one good thing, and it will not go to the sewer lines. Now, catch basins need periodical cleaning, as otherwise the settled organic matter may decompose and producing foul odors. And at the same time, the another one disadvantage of catch basin is, in these catch basins this breeding of mosquito happens. So that is why you can consider these catch basins as the breeding place. So we have perforated cover at the top, as you can see in this case, and that is provided at the top, through which the rainwater comes down. Now, remember, catch basins were considered necessary in old combined sewerage systems. However, in modern days, they are not considered as very essential, because the modern well-paved streets offer very less grit and debris with storm runoff. That is very true. So you need not to put so much money in just only constructing the catch basins, since your the concentration of grit and debris are reduced significantly because of the you know enhancement in the quality of the streets and roads and the quality of the pavement. And these things are actually getting sorted out with days, and then most effective techniques, when we are adopting them. I can tell you another one example. That the same thing are happening in case of stormwater sewers laid at suitable gradients to provide the self-cleansing velocities. So, moreover, the problem of eruption of foul gases from stormwater sewers is very less, and as such, there is not much necessity of providing such basins in modern day separate sewage systems. So, mostly you should remember that catch basins were used in case of combined sewage systems. So, next is regulator or overflow device. So, what is this regulator or overflow device? Now, these are used for preventing overloading of sewers. Right? Remember, so these are regulator or overflow device. They are used for preventing overloading of sewers, pumping stations, treatment plants, or disposal arrangements by dividing the excess flow of two relief sewer. Right? So the overflow device may be side flow or leaping weirs according to the position of the weir, siphon spillways or float actuated gates and valves. So there are few new terms which we are actually listening. So in the moment I discuss about different type of regulator or overflow device, you should be able to understand is better. Now the first one is side flow wear. Now in side flow wear, we have, it is constructed along one or both sides of the combined wear and delivers the excess flow during storm period to relieve sewers or natural drainage occurs. Now you can see in the left hand side we have that side flow wear. So there is a combined sewage sphere and a parallel sphere is actually placed, and that is connected to the combined swell. Now during the monsoon or during the precipitation, as soon as the level of the water or flow level of the water within the combined swell upsurges, then after a certain point it will reach to the connection pipe to the relief swell, and thereby the top water, which is the which has very less amount of debris and other biosolids, will move to the relief spares, and thereby what we can do is we can reduce the load on the main combined sewers. Now so during the storm period, to relieve sewers or natural drainage, relief sewers are used to reduce the load on the natural drainage, and the crest of the weir is set to an elevation corresponding to the desired depth of flow in the combined sewer, which is actually shown. Now, the weir length must be sufficiently long for effective regulation of the flow. So this is very true. Now, in the right hand side, you can see that we have shown the overflow wear arrangement. So, in this case, what is done is, there is a combined swear, and then we have an adjustable plate. Now, when the swear is running full, we will just simply lower down the adjustable plate, and then the uh, extra switch, because of the precipitation, will then move from the top part, and then that would actually go to the relief squares, and this is the way overflow wear works. Fine. Now next one is leaping wear. So leaping wear is another one type, which basically another one type of regulator or overflow device. From the name or from the figure which I have shown here, you will be able to understand that this is also a regulator or overflow device. So how does this leaping wear work? Let us discuss. The term leaping wear is used to indicate the gap or opening in the invert or of a combined wear. Now, the leaping wear is formed by a gap in the invert of a sphere through which the dry weather flow falls and over which a portion of the entire storm leaps. Right? So this has an advantage of operating as regulator without involving moving parts. However, the disadvantage of these wear is that the grit material gets concentrated in the lower flow channel. Right? From practical consideration, it is desirable to have moving crest to make the opening adjustable. So the crest, if we can have adjustable crest, then that would actually increase the efficacy of the leaping wear. Now, when the discharge is small, the swage flow falls directly into the intercepting sware through the opening. But when the discharge exceeds a certain limit, you will understand that then the velocity will also increase, and then the excess swage lifts or jumps up across the wear mouth or intercepting sware, and then directly move to the next part, and it goes to the river, because we don't want treatment for the storm water swage. But when the discharge exceeds a certain limit, so the jump or the lift up water will move across the wire, and then it is carried out to the natural stream or the water body. So the same has been shown in the right hand side figure. I guess all of you would be able to understand or can be able to relate with the what I am discussing. Next is float actuated gates and valves. So what is float actuated gates and valves? That is another one type of regulator or overflow device. So the excess flow in the sphere can also be regulated by means of automatic mechanical regulators. So this is the smartest way to maintain or to regulate the excess flow. And these are actuated by the float according to the water level in the sump interconnected to the spheres. And since moving part is involved in this, regular maintenance is also required in this case. So any sophisticated appurtenances you use, the maintenance and service should be there. Otherwise, that will create problem in long run. So if you maintain and frequently, and if you service them frequently, they will run, and they will run with great efficacy. Next is siphon spillway. Siphon spillway is another one type of regulator or overflow device. So this arrangement of diverting excess sewage from the combined sphere is most effective because it works on the principle of siphon action, and it actually operates automatically. Now let us see how it works. So the overflow channel is connected to the combined sphere, as you can see in this case, through the siphon. So we have a siphon that consists of and then the entire siphon spillway, it consists of a overflow channel. You have a combined sphere, and then you have a siphon, and you have an air pipe. So what happens is the overflow channel is connected to the combined source with the siphon, and an air pipe is provided at the crest level of the siphon to activate the siphon when water will reach in the combined sphere at the stipulated level. So what happens is when it reach to that particular level, the siphon action will get started, and then the extra water will be taken out to the overflow channel. So this is the way siphon spillway work. This is also very important appurtenances which one should keep in mind and discuss. And then finally we have the flap gates and floodgates. So flap gates and floodgates. So flap gates or backwater gates are installed at or near the sewer outlets to prevent backflow of the water during high tide. So this is also very important. So we always have to have such kind of mm, arrangement, so that there is no backflow of the water during high tide or at high stage in the receiving stream. These gates can be rectangular or circular in shape, right? Okay, एक second. So, flap gates and floodgates. So, from the name itself, you should understand these would work like a valve. So, these gates can be rectangular or circular in shape, and these are usually made up of wooden planks or metal alloy sheets, which will not be rusted easily. Such gates should be designed, such that the flaps should get open at a very small head difference, and adequate storage in the outfall sphere is also necessary to prevent backflow into the system due to the closure of these gates. at the time of high tides if pumping is to be avoided. So this is the way flap gates and floodgates are used, and they are also very significant appurtenances needs to be installed in the sphere systems. Now next is the sphere ventilator. So we have different type of ventilators, and sewage ventilation is a very important part. So this is one thing which I would like to discuss in detail. So maybe in subsequent classes I'll be discussing them about sphere ventilators. And if you see your syllabus, I don't know how many of you have gone through. So we have almost finished Unit 3. We have almost finished. So slide part is there. Probably by the end of this week, we'll be able to finish the so this so we have discussed about appurtenances. So ventilation in detail I'll discuss, and then maintenance and inspection will also be covered by the help of maybe by the end of this week we'll finish them. Just 1 second. So let me stop the recording first.